teachers and all my dear friends. We Beauty and Laku from Standard 8 are here to deliver a short speech on Ramanujan's birthday. Today we gather to celebrate one of the famous mathematical genius India has ever produced. Yes, we are talking about Srinivasa Ramanujan. Srinivasa Ramanujan born on 22nd December 1887. Ramanujan showed us that true talent needs patience, dedication and faith in one's abilities. Ramanujan's journey was not easy. With a very little formal training and limited resources, he explored the infinite world of numbers using pure intuition and imagination. To him, mathematics was not just a calculation, it was a language spoken by the whole universe. One of the most famous stories of Ramanujan was the story of the number 1729. When the great mathematician G.H. Hardy visited him in hospital, he mentioned that he took a taxi of the number 1729 and felt it was one of the dull numbers. Then Ramanujan immediately replied that 1729 is a very special number. Then he explained that 1729 can be expressed as the sum of the two cubes in two different ways. Like 1729 is the sum of the cube of 1 and 12, and it can be also expressed that 1729 is the sum of the cube of 9 and 10. This instant insight amazed Hardy and the whole world. And today 1729 is known as the Ramanujan's number. Ramanujan's life and even in the darkest circumstances, his contributions inspired mathematicians, scientists and even the students across the globe. On this National Mathematics Day, let us remember Ramanujan's legacy and start to think beyond limit just as he did. Thank you. The student of DPS the students of DPS has performed many projects on this National Mathematics Day. Sir, starting soon. Now, the students of DPS has made many projects to celebrating his birthday. Now we are gonna to introduce that project. Now I am going to showcase the working model of cube and cuboid. As you can see here, the volume of the cuboid and the surface area, and the volume of the cube and the surface area of the cube. Now I am gonna to tell you this one is Ludo based on the linear equation. This one is same. This one the number system Pythagoras theorem, and this also Pythagoras theorem. This also the number system, and this one the working model of cube. And this is based on the working model of cylinder, as you can see here. And this one is a angle in a semicircle. This is 90 degree, and this is sector, and this one is segment, and this one is AB diameter. Now this is the important theorem of circle, like central angle theorem, angle on the same segment, cycling quadrilateral, and equal chord equidistance theorem. And there are the areas of circle and the circumference of the circle. And this is also same equichord equidistance. And this is based on the Monty Hall problem, as you can see here. And this one is Fibonacci sequence. This is also known as the golden ratio. And there is the application of Fibonacci sequence, what is golden ratio, and the Fibonacci sequence actually what is. And this one is the property of a polygon. Sum of all exterior angle is equal to 360 degree.
conjecture. The Collas conjecture was introduced by the German mathematician Lothar Collas in 1937. There are certain rules that we have to follow in Collas conjecture. Let me tell you. First we have to take a number. Let us take an example, like we have taken the number 16. First, if the number is even, then we have to divide it by 2. Like this number is even, then we have divided it by 2, 8. Again the number is even, then again we have to divide it by 2. If we are getting the number odd, then we have to multiply it by 3 and add 1. Likewise, we will follow the rules until we reach the 1 at last. For every positive whole number, it follows the same sequence. It will always reach 1 at the last. But there is no general proof.